What is up, everybody? We should be live here. Um, and we're going to break down the severe weather threat coming up over the next week or so. I couldn't get my microphone to work on my PC, so I'm going to have to go with the microphone, the phone audio. So it might not sound 100% perfect, but we're just going to have to let it be. I got the Oklahoma City Thunder hat on. Got the game going on in the background here, so it's a pretty tight one. So we got a slight risk for severe weather tomorrow across the Dakotas and Nebraska, even extending all the way into far northwestern Iowa and far southwestern Minnesota. Got a big 2% tornado risk, so very low tornado risk, and we'll break that down in a minute. Why it's such a low tornado risk tomorrow and why the other days are a little bit higher. But already have a day three. Already have a day three enhanced risk across Wisconsin. It's hatch too. They get the hatch risk all the way. So welcome in everybody. We're gonna go look at some models here. Why don't we look at our good friend in 24 hours? When what model, what cam really is accurate? 48 hours out. So hold on. Let me pull up chat here. Ever doing this, guys? This is my first time ever doing this. I kind of like talking about weather, so I think this is something I want to do. I forecast and then just have a good time in here. What's up, guys? How's it going? Beth, Mary Ann, good evening, everybody. All right, so let's go ahead and start breaking this down. So we have our trough here. About right now, we have this trough sitting out here across the western U.S. There's our big trough right there. And this is going to push east. And we did have another cutoff low. So, as you guys know, the reason why we haven't had much robust severe weather the last week is because we've had kind of two troughs. We've had one over here and another one over here, and they've just kind of been spinning right next to each other. And so that's caused offshore flow, so moisture couldn't get up. So, um, as we go throughout the next couple of days, this trough is going to push the other one out. So, as this trough, by tomorrow evening, this trough begins to eject over the plains. We got our trough right here, our big system, our wave of energy. It begins to eject over the plains here. And this trough over here is getting pushed out. And that's going to set the stage for big time severe weather in this area. Even a bigger area, probably more like this over the next week or so. And even farther out, past a week, but it's a little bit hard to tell, guys. What's up? How's everyone doing? Welcome in, welcome in. This is a different type of thing than what I usually do, but we're running with it. I want to see how this works. So if this stream here goes good, I might as well go live tomorrow. But as you can see here, tomorrow night our trough is ejecting into the plains, and that's going to spark. Let's see if I can change colors here. That's going to spark severe weather across the Dakotas, Nebraska, Iowa, Minnesota, right up here. That's going to spark your severe weather. And then as we go into Thursday, our trough moves east and becomes more negatively tilted, and it becomes stronger. So as your trough moves east, it becomes stronger. We have that negative tilt. So when I say negative tilt, that means that if I drew a line through the axis of the trough, that line would be from the northwest to the southeast. That is a negatively tilted trough. If I could draw a line this way from the northeast to the southwest and my trough looked more like that, then it would be a positively tilted trough. Both of them can give you severe weather. Oftentimes, the worst severe weather is associated with a negatively tilted trough, although it just depends. Um, but we have this trough right here, and we actually have we have two waves of energy here. So let me show you guys here. We have our main trough up here, and then we have like this this is what we call the Baja jet. So we have this subtropical jet that's streaming off the Baja Peninsula. Look at this strong jet stream right off the Baja Peninsula, and that is just another piece of energy there that's that's coming right into the Ohio River Valley. and that could set off some storms. But we kind of have a weird thing. We have like a dueling waves of energy here. So we have one up here to the north, and we have one down here to the south, and that's gonna be interesting because you're forcing and um, your big energies up here. And you have another piece of energy down here, but the best environment is kind of located maybe somewhere in the middle across southern Wisconsin and northern Illinois. So the question is, are we going to get storms in that environment? And that's what we're going to have to break down. But first, I'm going to touch on tomorrow just very briefly. We're not going to focus a lot on tomorrow. I'm not going to be chasing tomorrow. I'm going to be working. So not going to be chasing. What's up, Michael? Derek? Marianne, Derek, what's up? Sydney, good evening, everybody. Good evening. It's a little late tonight. I would rather have gone live more like 8:30, 9 p.m. But this is just what we had to do. So tomorrow, if I do a live tomorrow, which I probably will, I want to start doing these as much as I can. It'll be hard once I get out onto the road and start chasing, but I want to do these as much as I can here. Um, so we can look at our moisture, and this is why tomorrow is not going to be that big of a tornado risk. And you can see here, this is where your storms are initiating up here. And at this point in the day, you have mid to upper 50 dew points, which just isn't enough. And then by the time your storms initiate, you have middle 50 dew points. This might be underdoing it a little bit. They might be a little bit closer to 60. But still, if I take a sounding out there in Nebraska, Freddie McKinney might have to chase tomorrow. Well, you're going to be chasing those high spread storms, and you can see tomorrow across Nebraska. Look at these spreads. You have this big V shape here. So that red line is your temperature line, and that green line is your dew point line, and you have this big old V shape right there. And that's usually not a good thing for tornadoes because that means that your dew point and your temperature are very, very far apart. So 30-degree temperature dew point spreads here, and your LCL, that's the cloud base. Your LCL is all the way above 2 kilometers off the surface, and that will come down with time. And this model, the HRRR model, might be just a little bit dry there. Whoa, what happened there? Might be just a little bit dry, and you can see towards about 8, 9 p.m., your LCL does come down. Those temperature dew point spreads are closer to around 25, and you actually do have a decently curved hodograph with some good directional shear. Southeasterlies there, got southwesterlies up here, some pretty good directional shear there, and that could be enough for some supercells and an isolated tornado threat. Now, I still think those temperature dew point spreads are really, really far apart. So we're going to have to see on that. Those dews at O2Z aren't bad. No, they're pretty good, actually. I'm working tomorrow, so I'm not going to be chasing. But let's see here. At O2Z tomorrow. Let me take a sounding there, guys. Forecast sounding just kind of models the environment, kind of shows you what a storm might do, and that's actually pretty nice. Maybe I should be chasing tomorrow. That's not bad at all. But you can see here now your dew point temperature spread is only 20 degrees, and see how you don't have this V. You kind of have like this going this way and this going. You don't have a V anymore, so that is not a bad look at all there. And your hodograph. This kind of just tells you, your hodograph is going to tell you how winds are changing through height as far as direction and speed goes. So you can see that's a nice hodograph right there. That would be supportive of a tornado threat if you had an isolated storm. Your problem is if storms fire before this, they're going to go upscale and they're going to be very dry. And you can see this on this model. These kind of have upscale dry storms, but if one of those can become a rooted supercell, it could produce tornadoes. The other models kind of have the same thing. So I don't want to do that. Very dry there. And let's see. Yeah, I mean, none of these models really have right moving supercells with a lot of moisture. Mason Harris. Let's see what Mason has to say. I'm working tomorrow too. It burns to have to miss one so close to home. Colorado season's coming. Yes, Colorado season's coming. The rains have been plentiful. That moisture is juiced up. Colorado season is coming. So let's go take a look at. How about we go take a look at Thursday here. So Thursday we have our enhanced risk right here. Um, so from just to the east of Minneapolis all the way down to Madison, and then you have a slight risk for Chicago, um, Detroit, Indianapolis, Dayton, Cincinnati, Gary, Indiana. Um, you have about, let's see, you have about 33.5 million people in that slight risk. That's a lot of people in that slight risk. And then you have only 2 million in the enhanced. I bet the enhanced risk will probably get extended a little bit further south there into northern Illinois. Right now, the Thunder just took the lead. So watching that game in the background. So let's go here and focus on Thursday. So let's look at our 500 millibar wind pattern. So these are the winds, maybe 6 miles. I believe like 6 miles above the ground. 500 millibar winds. You can see here, this is a wrap model. I think it does an okay job. You can see by about 5 p.m. here, you have our big trough, just a big trough here coming into these areas. You have a lot of defluence. So you have winds up here out of the north, and then the southerly Baja jet winds out of the east up there, and then out of the out of the west, and then you have ones out of the southwest there. So that is spreading the atmosphere apart. And whenever you get the atmosphere to spread, what's the tendency um, when something spreads apart? Well, something's going to come, fill in that gap, and that gap is going to be thunderstorms, right? So those thunderstorms are going to fill in that gap. So you have some decent diffluence, especially up here into Wisconsin. Better forcing up here, and you're going to have a big arc of supercells marching to the northeast up there. And we'll see that in some of these models here as we look at them. But what I want to do is I always try to look at the models from above first, and then kind of take what I see above in the atmosphere and kind of try to figure out what that might look like as we go down. So I start up in the atmosphere with my forecast, and then I work my way down to the surface. And you can see our 850 millibar winds. These are going to be winds about a mile, or well, maybe closer to 2 miles, mile or two above the surface. Share and welcome to the Doppler gang. Thank you for becoming a member. They're going to be about a mile or two above the surface, and you can see we have a pretty strong low-level jet, 35 to 40 knots there across southern Wisconsin. Actually, this HRRR is a little bit to the east. Our low-level jet's going to be more right here. I think this model is actually going to trend west, so it'll probably be more over here at 7 p.m. This is for 7 p.m. on Thursday, by the way. So this is for Thursday. But we have about a 35 to 40 knot low level jet, and that's not a ton. That's not a ton, but this time of year when you have such good moisture and instability, that's all you need. You really only need 30. Well, in some cases, way less, but only 30 to 40 knots for a significant tornado threat this time of year. So let's go look at what's going on at the surface. I'm going to look at our dew point. And sorry, this is the wrap model, not the HRRR. But you can see here, here's our surface low. You can see our surface low all the way up there in Minnesota. So that surface low is bringing in dry air behind it on the southwest side, and it's bringing up that moist air on the easterly side of that low. And that's going to give us what we call a Pacific dry line. So it's not like quite the kind of dry line you'd see out in the plains where you'd see like 70-degree dew points to the east, and then it dropped to like the 30s. And it'd be like 100 degrees behind the dry line. It's not going to be quite like that. It will be pretty warm behind that dry line, but I'd call this more of like a Pacific front or Pacific dry line. And you have really good backed winds, lots of moisture on that east side of that Pacific dry line, and you have a big time surface low all the way up here, and all the forcing is north. So you're going to have you will have a big line of storms up up here, you're going to have a big line of storms. The question is, do we get stuff to fire down towards Chicagoland, the Cobb, Northwest Indiana, even all the way down into I-70, all the way towards Springfield, Peoria? What else is down there? Maybe is there somewhere called like Decatur? Um, you're going to have the question is, are we going to get storms down there or not? And let's take a look at our environment here by 22Z. I'm just going to pull a random sounding there in northern Illinois. And wow, that's a good looking sounding for tornadoes if you have storms. So, according to the RAP model here, our cap is completely eroded. So, you see that yellow, hold on, let me draw that better. You see that yellow lettering, the LFC? That's your level of free convection. Okay, so if the level of free convection is touching the lifted condensation level, which is your LCL, that means that your cap is essentially eroded. And you can see here, this red line is your temperature line. And you can see that temperature line is pretty cool right there. So that cap is gone. That cap is eroded. And then your dew point line is pretty close to that temperature line there. So your LCLs are low, your cloud bases are low. You have good 3 cape. You have pretty big cape. This is a pretty big cape profile right here. So between that red line and that white dash line, that is how much instability you have. So the fatter that space is in between those two lines, the more instability you're gonna have. And then the space between this red line and this green line right here, that is what we call the elevated mixed layer. So that is showing you how dry or how moist the air is as you go up into the atmosphere. You can see down here is at the surface, 1 kilometer, and then you see 6 kilometers over here, 9 kilometers over here. So these graphics and diagrams look intimidating, but if you read them a lot, you get used to them. But you can see here we have a lot of dry air, in this column for Thursday, and then we have a lot of cape, moist surface. If you get a storm in this environment with an okay hodograph, it's pretty good. If you get a storm in this environment, it can produce very photogenic tornadoes, photogenic storms, photogenic supercells, very visible. Um, that would be my expectation in an environment like that. And if you go to let's go to 0Z here and let's take a sounding over Chicago. Well, that didn't work. Let's take another sounding over Chicago, and you can see your hodograph gets even more looped. So that hodograph, the more of a loop you have in the low levels, the stronger that low level shear is. So if you guys have any questions in the chat or some of this stuff is not making sense, feel free to ask. I'm always open to answering anything here. Let's see. I'm always open to answering anything here. And the Oklahoma City Thunder did pull it out, so that's good here. The Oklahoma City Thunder did pull this one out. So let's go look at some cams for tomorrow here. Let's go look at some cams for tomorrow. Hold on, I'm gonna bump this post on. I'm gonna post this feed on. I'm gonna post a link on Twitter. Sorry, I cannot talk. I'm gonna post the feed to this YouTube here on Twitter. Maybe get some people in here. Just give me a second, guys. Make sure to like that stream. If you have questions, like I said, comment down below. Helps the algorithm out. Helps me out. Sub to the channel, guys. I'm going to be out chasing this stuff. So right now I'm just breaking this down, but I'm going to be all out this week chasing this stuff. We're going to go into the never stop chasing grind here. Hold on. Let me just get this link copied here onto Twitter. Oh, you can see here we have one model that's firing storms over western Indiana, but it has like nothing over the Chicago area. We can look at another one here. That's a mess. This is probably what's actually going to happen. If this is what it looks like on Thursday, I wouldn't be surprised. There's a chance I don't chase Thursday. We'll just have to see. Um, we'll have to see if I end up chasing on Thursday or not. It's going to depend on how all this stuff looks. Let's see. What's up, Chris? What's up, Trey? Sydney, what's up? W Sharon, heck yeah, W Sharon there in the chat. All right, let's get this copied. Sorry, guys. And then I'm going to get back to the forecast. Okay. All right. So let's look at some convective allowing models and just FYI, we're still 2 days away here, so these aren't going to be entirely 100% accurate here, but we can look at them. So you can see here, this is a model, the NSSL model. It's a decent model, not my favorite, but also not my least favorite. Sometimes it does a really good job. And here, this model tries to fire. This model tries to fire supercells across the Wisconsin-Illinois border area, and then it kind of tries to fire an arc of supercells up there into the woods of Wisconsin and Minnesota, but can never quite get it done. The driftless area, I believe that's what you call it. And then it fires like a messy outflow dominant cluster of storms uh, down into southern Illinois, and I wonder why. I wonder why it's firing these outflow dominant storms and not right moving surface based supercells. Maybe we can take a sounding and look at the environment, and that'll tell us our answer. Um, Looking at the sounding, it looks pretty good. I actually don't know why it's firing those storms like that. Down to the south, it kind of makes sense though, because if I pull a sounding down there into southern Illinois, you can see you kind of have a wonky thermodynamic profile down there, like non-existent curve in your low-level photographs is a little bit, but up here into up here into those storms, this might just be this model being weird because up here into Wisconsin, it looks like a pretty solid environment. Let's look at the other age shot. And okay, so this one tries to fire some robust supercells across central Wisconsin into that enhanced risk. You're probably going to have an arc of supercells right here along that Pacific dry line, but it doesn't fire much down in northern Illinois. It kind of tries a little bit, but doesn't really fire. And then it fires a couple supercells over into western Indiana, which we're going to have to watch. I wonder what the environment would look like down there in Indiana. You can see here where these supercells fire down in Indiana. Yeah, really high temperature dew point spreads. There's some curvature in that photograph, so you probably get supercells. But I don't know if you had thermodynamics like that. If you had temperatures that were 90 degrees at 6 p.m., you're probably not going to get a big tornado threat, especially this time of year. You know, to get a big tornado threat with a 90-degree temperature, you probably need dew points in the mid 70s at least, not in the upper 60s. So we're going to look at one cam that was interesting was one that came out this morning, and this data is kind of old, so take this one with a grain of salt because this is kind of old. But look at this model. Look at this. This prints supercells across Wisconsin and Illinois. So you have like kind of more of a linear mess up here, and I'm assuming maybe a little bit too much forcing up there. Maybe a little bit more upper level winds out of the southwesterly. Maybe you don't get the convection to move off of the initiating boundary, but down here you have a little bit less forcing, and that sets the stage for possibly some isolated supercells. Look at this. You got 1, 2, 3, 4, 5, at least 5 isolated supercells that this model is firing. And if something like this happened, I'd be seriously concerned about significant tornado potential. And look at that. I mean, they just grow into just to the south of Madison, over towards Chicago. Don't take this with verbatim. This is just one single model run. This is the impasse model. But it's showing the potential, and then you can see around 8, 9, 10 p.m. They kind of wither away into nothing. So they fire up pretty vigorously by about, they don't fire until like 5 or 6 o'clock, and then they get strong for a couple hours, probably produce tornadoes in this environment that you're going to have, and then they die. So look at one more model here for this. We'll look at one more model for Thursday, and then we'll jump up to this weekend and early next week, which looks pretty big time. Maybe further west across the plains. This model, the NAM 3K, it's not really my favorite model to use, but it is firing an arc of supercells there across southeast Wisconsin and eastern Illinois. So that's interesting. It's been pretty consistent with that. Look at one more model. This is a brand new model. I've never seen this model before. I don't know if it's a new model. I've just never seen it on this website before. I've never looked at it before. I have no idea if this model is any good or if it's hot garbage. But here we go. This one tries to fire that arc of supercells once again across southern Wisconsin into northern Illinois. And it actually fires some pretty vigorous convection all the way down towards I-70 down east of St. Louis, which is going to be a focal point for Friday. We'll have to touch on Friday here in just a minute. I'm about to touch on Friday here, but kind of go over Thursday. So this is kind of what we're expecting Thursday. Surface lows up here in central Minnesota, and we're going to have that arc of supercells. And they might fire down here into the slight risk. They're probably going to fire up in that enhanced risk. The environment's probably the best. Madison, Wisconsin, southward all the way to DeKalb or southwest of Chicago, into northwest Indiana. And it's a little bit harder to get stuff to work when you get really close to the lake, but it's a good environment all the way to the Lake Michigan. So that's kind of what we're expecting Thursday. I'm planning on chasing this event Thursday. If it really looks like it's just going to be in the North Woods in like Wisconsin and the Driftless area, probably not going to drive. I'm seriously probably not going to drive 10 hours to chase in mountains and trees with zero service for a stream. I'm probably better off just waiting for Friday, maybe working another shift on Thursday. But let's move over to Friday, and there's already a risk out here, and I bet this ends up being a moderate risk. I'm putting my money on it right now. By day one, it's a slight risk right now, but by day one, this is going to be a moderate risk. Putting my money on it from probably south central Missouri, north central Arkansas, all the way over up into the Ohio River Valley, Louisville, Evansville, Indiana, Mount Vernon, Illinois, probably all the way up almost to St. Louis. We'll see how far up it gets. And Indianapolis, Dayton, you might be even in play there. Welcome in, everybody. That will get expanded north, says Andrew Griffiths. Yeah, I agree. I guarantee Jeffrey says there's a huge gap in the live streams. No one's educating. Well, I'm here to educate, have fun. I'm here to do everything. So I guarantee. I really think that's gonna. We'll see how things play out. But I really think that's gonna be a moderate risk by day one, even if it's just for wind and hail, which it feels like the Storm Prediction Center. I feel like their forecasting has changed. I feel like they don't. As often roll with wind and hail driven moderate risks. They usually only go moderate if it's a tornado driven moderate. I don't know, especially for hail. I notice they never do hail moderate risks anymore. But we're gonna look at our 500 millibar pattern here and look at some of this energy that we're gonna have for these storm systems. So these brighter colors, these yellows, these reds, these pinks, these blues, those indicate kind of atmospheric energy, okay, or vorticity. So you can see here, we're going to go, I'm going to play this on a loop here. So here's our trough right here. This is our trough out here. You have a lot of energy over the Mountain West right now. And as this trough moves in, that energy kicks into Nebraska tomorrow, and that's going to set off your severe weather in Nebraska. And you can see this lobe of energy, this trough, continues to move east. And then by Thursday, which we just broke down Thursday, I'm not going to touch on it too much more, but you can see upper level low right here. And we have a upper level low right here, and we have a big piece of energy up here to the north. And then we have another piece of energy, like I mentioned, that Baja jet, that subtropical jet. You have another piece of energy across the Ohio River Valley and I-70 and south. And then let me get rid of that. There we go. And then as we move into Friday, look at that energy reload all the way across the Ohio River Valley. There you can see a little bit of a burst of vorticity down there, and your main trough is still up here. And as we go through Friday, Saturday, look what happens. You have another little shortwave trough across the Red River area, Arkansas, Oklahoma, Texas. You have another wave of energy, and that's going to set off more severe weather Saturday in the Red River area. And then Sunday, our big boy comes in, okay? Our big boy is going to come in on Sunday. And you can see, look at this trough by Sunday. Just everything just reloads. We're going to have plentiful moisture. We've had return flow now for like a week at this point by the time we get to Sunday and Monday. So you can see, okay, so here's Sunday, and you can see our main trough Sunday is still out over here. Maybe if I switch colors a little, let's see, let's go with black. Yeah, our main trough is still right out here over the Mountain West, but you can see this trough is impinging on the plains, and you can see there is a little bit of energy here to kick off storms across the southern plains. We'll have to watch that. So Sunday, I bet you have a dry line, and you probably do have supercells. You have enough of a kick from this system, and it's a big negatively tilted trough once again. Those negatively tilted troughs usually have a little bit of an extra kick with them and can help initiate storms. And as we go through here, Monday could be the big day here. So as this trough, as you see, this trough moves east here. Let me see. I can't tell what tilt it is off this map here, but this trough moves east, and you can see that energy is coming out into the plains. And then, so that's Monday. Monday's going to be probably the big day. That's going to be the one we really got to pay attention to. And then you can see Tuesday. Look at that. Your main wave Tuesday ejects into the Midwest and the Ozarks, and you're probably going to have another significant severe event on Tuesday, as long as the trough does not kind of get sheared out. And when I say trough getting sheared out, that means the trough is kind of pulling itself apart. The trough pulls itself apart and it gets weaker, and then maybe loses kind of its amplitude. So as long as that trough doesn't shear out too much by Tuesday, which they can have a tendency to do, we should be all right. I'm going to actually go. I think I actually might have a new run here. The 0Z. What time is it, guys? I don't want to keep this thing going too long. It's already 11:24. I'll probably stay live. A little bit longer here. We're going to break down some of these setups here. What's up, guys? Zabin says, Ben with an exclamation point. Let's go. So you can see our 0Z looks about the same. Look at that main wave of energy just kick across the plains. We're gonna look at this here in a second. So let's move on and look at Friday, Saturday, Sunday, Monday, Tuesday. So I'm somewhat excited about Illinois Thursday if we can get a storm in the right environment. I'm really excited about chasing Friday, Saturday, Sunday, Monday, Tuesday. That's going to be an insane 5-day severe weather stretch, and we might have more after that. We'll have to see how this pattern potentially reloads again into the last few days of May. We could get we'll touch on that. How about this? We'll touch on that 5-day stretch, and then I'll kind of go look at the long range a little bit. So by long range, I mean probably like the 21st, 22nd, and on. So the last week or so of May would be the long range. So I'm just gonna go look at the 0 to 3 kilometer energy helicity index. And so basically, what this map is telling me is it's telling me where the best combination of instability and wind shear is. So what do we need for storms and tornadoes? We need instability and we need wind shear. And this graphic here is going to tell me where the best overlap of instability and wind shear is. So you can see I got to make sure I'm on the 0, 0 in Texas. But the reason why there's no storms today is because if I click a sounding right here, here's a little bit of an education. It's your temperature line. And look at this red line. So your cap is like this big layer of warm air that kind of puts a day. And that is limiting storms from firing, even though we have a great environment across the plain. Moisture's high at the surface, but your depth of moisture throughout the whole column of the atmosphere is low because it's just now coming on shore. So then tomorrow, we move tomorrow, and we once again have a lot of energy here across the central U.S., but a cap and no forcing to get storms. And so we go Thursday. There's our Thursday threat. You can see that energy move across the Midwest. And then here's Friday, guys. Here's Friday. And this is going to be a really big setup Friday. So you're going to have a big warm sector here. So we're talking all the way from southern Missouri, all the way down to southeast Oklahoma, northeast Texas, all the way up through Arkansas, over the Ohio River Valley, all the way into western Tennessee, and even parts of southern Michigan and southern Wisconsin. Now that's where your whole warm sector is. And by warm sector, I mean just where the instability is. So where you have instability. Now here's where your threat is going to be the highest. Your threat is going to be the highest right here from south central Missouri into north central and eastern Arkansas over across the Ohio River Valley, all the way up to I-70, St. Louis east, maybe up to Indianapolis. We'll see. And like I said, I'm putting my Ben, you're lagging it fixed. Am I good now? Guys, in the chat, let me know if I'm good or not. Am I good? Am I good? Am I good? Am I good? Check, check, check. Is it working now? Zabin says it's fixed. Guys, shout out to Zabin. He set a lot of this stuff up for me, streaming wise. Shout out to him. He also helped me build my PC. I would say helped. He did most of it. Okay, we're good. We're good. Okay. Well, we just lost half our viewers. That kind of sucks. That kind of sucks. We just lost half the viewers. Okay, but so yeah, that big blue area, and then that main risk is going to be south central Missouri, northeastern Arkansas, all the way across the Ohio River Valley, all the way up to I-70, St. Louis to Indianapolis. That's where that main risk is going to be on Friday, and this could be a big one. Okay, so Friday, here's what I am looking at Friday. That'll let you guys know what's going on. Let's see what hour. Yeah. Let me get in on this here. Okay, Friday. If you look at our surface pattern on Friday, this is a wonky surface pattern, and that kind of stuff matters. You'd think, oh, you just need a good environment or some forcing to get tornadoes, which sometimes can be the case, but your surface pattern does matter. You can see here your main surface low is kind of like up in this area somewhere up here. And then you kind of just have a cold front right here, and then maybe a warm front right there. You don't really have any kind of surface low or deepening in the surface pressure. Well, you do have increasing surface pressure out ahead of the cold front here, but not a ton. So you're kind of like a weird setup here. So I think this could get messy, possibly. But here's what it has going for it. So you have this shortwave trough right here. So yeah, your main low of the trough is up here. You have your kind of, look at this Baja jet, like I talked about. That Baja jet is that separate jet extension to the south. K Jack, welcome to the Doppler gang. It's that separate jet extension to the south. So here's the Baja Peninsula, and that southerly jet just rips off that Baja Peninsula, and it provides extra oomph for these severe setups. So you do have a nice little short wave right here, and that's going to set the stage for big time severe weather. We'll go look at our 850 millibar winds, and this is huge right here. If you go to 7 p.m. here, this is insane for this time of year. Look at look at this. You have 40 to 50 knots of wind, maybe a mile or two above the surface, just ripping. And that's how you get those big, strong mesocyclones to drop tornadoes. That is actually genuinely impressive. I think this setup has uptrended. Probably see an enhanced risk tomorrow. We'll see. But look at that, 50 to 45 knots flow. And if you don't know, knots are kind of similar to miles per hour. So 50 knots might be like 60-ish miles per hour. So it's just a little bit less, but that's a good way to think of it. Let's see here. Welcome in, everybody. Make sure to like the stream. Let's see here. We're almost to 70 likes here. Let's get to 70 likes here, guys. All right, so have a lot of moisture. I'm going to pull some soundings here. These are probably going to be impressive, to say the least. So let me pull a sounding. This is South Central Indiana. And look at this. This is quite the environment here. Wow, look at that. Look at that hodograph. Just big hodograph, big time curvature. Storms moving out of the south. Storms moving there out of the southwest at 50 knots. So they're moving 55, 60 miles an hour there. This model is probably underdoing that elevated mixed layer. That elevated mixed layer, that dry air aloft is probably going to dry air aloft is probably going to increase there. So you have that big elevated mixed layer there. That's probably going to be more like that the day of. And then look at this. We talked about how we have space in between here. That's our instability level. You have a lot of instability here, and this is a global model, so it's not going to show as much as the convective allowing models when they come in. What's up, everybody? Welcome in. Welcome in. But this is a PDS tornado sounding. So here's your potential hazard type over here. PDS tornado sounding. That's indicating a very potent environment capable of strong tornadoes. And I've been on this setup for a couple of days now. I think I tweeted a couple of days back saying that there's going to be strong tornado threat Friday, and it's legit. And we can also go down here to the Red River, all the way down in southern Oklahoma. And I don't know if we get a storm to fire down here. You have a little bit of leftover cap, and you maybe don't have as much forcing. So I don't know if we do get a storm to fire down there into the Red River area. But if we do, there's going to be a big severe threat down here as well. Mainly a hail threat, but probably a chance for a couple of isolated tornadoes. And Saturday didn't ever look as impressive on the GFS. Let me see if I can pull a sounding in there on Saturday. But Saturday, going to be along the Red River. You're going to have here you go. Saturday, you have this little wave here, this little short wave right here. And this is going to this little short wave right here on the Red River, northwestern Texas, is going to kick off severe weather. You also might have some downstream over here across Dixie Alley. But the main severe threat Saturday is going to be right there, northwestern Texas into southwestern Oklahoma, kind of along that Red River, like I said. And then here we go. You can see here, Saturday, you have your threat right here. But then look at what's coming. There's that big boy. There's that big boy coming. That big trough is swinging through the western U.S. there. And that thing is coming to wreak havoc. Maybe wreak havoc. We'll see. We'll see how it all pans out. But it's definitely got the high-end potential to do so. And if we go to Sunday, here you go. So we go to Sunday, and this is when things start to kind of pick up. Friday is going to be a pretty big day, but this is when things could really start to kind of pick up. And you do have a you have a trough that's not really negatively tilted, but it's trying to get that way. It's amplifying. It's trying to become negatively tilted. And you can see you have some energy here out ahead of this trough. As it comes in, you're going to develop a surface low up here. You're going to have lee cyclogenesis on the east side of the Rockies as those pressure and height falls come across the western U.S. It's going to develop that lee cyclogenesis, and you're going to keep pulling that moisture up. You're going to have a classic dry line set up Monday and Tuesday. And if we go to our surface map here, we can look at our dew points and we can see that dry line. And wow, it's a pretty tight dry line. That's going to fire off some storms, isn't it? So you have a tight dry line, and there's that surface low right there in northeastern Colorado, right where it should be. But you have this dry line all the way from southwest Nebraska all the way down to northern Texas there. And you're going to have storms firing or all along this dry line moving off to the east. And you probably have a very potent environment. We're going to look in just a minute. Let's see what our low-level wind fields are looking like. So here's that low-level jet. And you guys hear me refer to the low-level jet. That is your wind maybe a mile or two above the surface. And you can see it's really strong up there into Kansas. You actually don't have that strong of a low-level jet down into Oklahoma and southern Kansas. And that actually might lower the tornado threat. But we'll see on that. We'll see. I would kind of think that you should have a stronger low-level jet down there than what you do on this model run. We can look at some other models. This is just the GFS model. So, of course, it may be right, it may be wrong. You can see we have some thermodynamic. So you don't actually have that strong of a low-level jet, but what you do have is really curved photographs there. And so this photograph, once again, shows us how the winds change direction and speed throughout the height of the atmosphere. You can see here, this photograph, it's kind of curved. See how it's curved like that? That means that your wind at the surface is out of this direction, and then your wind just above the surface is out of this direction, and that causes your storms to rotate. So that directional shear, good for tornadoes. And you have obviously very good moisture. We're going to have no moisture problems this week. No problems with moisture for these storms. We're going to have plenty of moisture. I want to go check out the Euro. I want to see what the Euro, that's short for European model. I want to see what the European model looks like on Sunday. And you can see the warm sector's pinched down into, I didn't mean to do that. The warm sector's pinched down into southern Kansas and Oklahoma. Let's take a sounding in central Oklahoma. So yeah, you got some weird thermo issues here on the Euro. We'll see. But once again, decent sheared environment. But the day to really watch here is the day that we really want to watch is Monday here. Let me go back to our energy helicity index plot here. Wow, so this is firing storms all up and down that dry line, huh? So we're going to take a sounding up here in central Nebraska. This is big time. This is big time right here. This is a big time photograph over here. Look at that. Just wow. Look at that curvature in the low levels. That's how you get strong plus tornadoes right there. Strong to intense tornadoes with that kind of a low level curvature. Pretty good thermodynamics. A little bit wonky in the low levels, but that might be worked out by the day of. You got to remember, it's Tuesday. We're still 1, 2, 3, 4, 5, 6 days out from all this. So we got time for these models to adjust, and the threat could either go down or go up, and we'll see. That's a pretty potent sounding here. So 50 knot low level jet at 1 kilometer and plenty of deep layer shear, big time cape, big time moisture. It's a recipe for trouble here on a Monday, and you can see, look at this. Here's your sim reflectivity, and look, it's just lighting up. GFS is lighting up the central plains with supercells there. Just lights it up. And then we can go to Tuesday. Let's fast forward to Tuesday, and you can see here by Tuesday that trough is going to eject east, and there's your warm sector. dry line moving east. Your warm sector is ejecting to the east there across Missouri, eastern Kansas, eastern Nebraska. By the time storms are ready to fire, you kind of have a boundary from southeast South Dakota all the way down to northern Texas. And you notice here these colors quite aren't as bright as some of the days before. So you might not have as much oomph in the atmosphere, but I still think you're going to have a actually really good environment for severe storms and tornadoes. And you can see that here as I pull these soundings. Really a lot of moisture to work with. It's not going to be, like I said, it's not going to be an issue. So I think Tuesday is going to be a tornado day as well. We'll have to see. Like I said, if that trough stays, I want to see what this trough looks like on the GFS. We're 168 hours out here. So yeah, if that trough doesn't shear out, so if that trough doesn't stretch itself out and kind of lose its amplitude, then I do think that Tuesday could be a big day. Welcome in, everybody. So these live streams, I want to do these. I think it's fun to do. I'm going to have better audio at some point. Got to get a different cord for my microphone. But we're going to go look at in the future. So we're going to go look at what's going on after this next trough. So remember this. Tomorrow, kind of a slight risk across central and parts of the northern plains. Main risk, hail, wind, isolated tornado there. And so tomorrow, slight risk. Thursday, bigger risk across Wisconsin, parts of far eastern, southeastern Minnesota, Michigan. It's to be determined. We'll break more of this down tomorrow. I'll go live again. We'll break more of this down. And then whenever the evening suit of models is coming out, we'll go live. But you can see that trough ejects Friday, and then Saturday you have another little trough, and then Sunday that big boy comes in. By Sunday you're gonna have that big trough come in, and there the trough comes in. Sunday becomes a more negatively tilt too. Big time severe weather by Monday, and then here's what we're watching. So now I'm gonna be live for a few more minutes here, and I'm gonna kind of break down what we're looking at in the long range. So we know that we're gonna have a severe weather stretch from Friday to Tuesday. Now, what's gonna happen after Tuesday? So about what is that? Would that be the 20, starting on the 22nd, 21st, 22nd and on? We got to see what's going to happen here. Welcome in, everybody. OKC hat. Yeah, OKC Thunder. I'm really like my number one team is the Clippers, but I will root for OKC second, and the Clippers got eliminated. So I gotta root for OKC. OKC 1 win away from the conference finals there. But we're gonna see. So this is gonna be interesting to see what happens. So this is what worries me in terms of having like robust severe weather. At the end of the month, as you can see, this trough. We obviously had a very strong trough come through. So what's gonna happen is this trough is like diving southeast. And so as this trough is diving southeast, you have this really strong troughing across the eastern US there. Really strong troughing across the eastern U.S. And what this is going to do is it's going to impinge into the Gulf of Mexico, and your moisture obviously comes from that Gulf of Mexico. So your moisture is trying to come up like this, but you have cold front coming down like that. That is a really messy drawing. Let me do that more simple. You have Gulf moisture trying to stream up north like this, and you have cold front coming down here. That's going to shut that Gulf down. So that's going to kind of shut down that moisture return. That's what I'm worried about. Now, if you don't get too strong of a trough, then it might not shut that moisture down. So, but see, you can see in this scenario right here, you might be able to get some moisture. You're going to be able to get a little bit of moisture to sneak back up into the plains, and you'll have some severe weather as you have little short waves come through on these troughs. But you can see, look at how strong this trough is across the eastern U.S. That's a really strong trough for this time of year. And that area of the country, that far south and that far east. So that is, you can see your wind barbs are out of the northeast or out of the northwest down there. So that could suck that moisture off the coast, and you're not going to get that return flow that you need for robust severe weather. So that could be one scenario. So this is the recent model run. Let me show you guys a different scenario. So we're literally going to go to the last GFS run. So if you guys don't know, these models update about 4 times a day. So they update 4 times a day. So I was on the most recent update. Now we're going to go to the update that happened in the afternoon, the 18Z GFS. And you can see what happens on this GFS is, look at this. Your troughing isn't quite as strong. It's a little bit more zonal. It's a little bit more zonal in that southeastern part of the US. And then look at this. You're able to get more troughs. You're able to get more troughs out to the west. So if we go in time here, look at what happens. It's not quite as strong. You get another trough, and then you get the strong southeasterly trough, but you have moisture up here. You have moisture sitting up here, so you still get severe storms. So let's go look at the ensemble quick. And if you don't know, the ensemble kind of puts everything together. So that ensemble is going to take all the data and put it together, whereas the deterministic GFS run or the deterministic European run, it's just one set of model data feeding into the model. This is a lot more data, so it kind of averages things out. And you can see here, there's our trough. There's our other big trough. This is impressive on an ensemble right there. That's going to be big, isn't it? We're going to see a bunch of 15% risks get added tonight by the SBC. And then you can see here that strong eastern troughing, and then we kind of might return to some zonal flow here. So kind of just a jet stream up here, kind of some zonal flow. And I want to answer the question of, like, is late May going to be active or not? And to be honest, I can't tell you. Like, I don't know enough. We don't have enough data. If I had to guess, I actually think we get another big trough in the last week of May. If I had to guess, I think we get another big trough in the last week of May, but it can't be for sure. And you can see here, this model is almost trying to hint at that. You can see right here towards the 28th, it's trying to hint at a trough right there. So it's trying to hint at it. So guys, let me answer some questions here. If you got, okay, I got a question for the chat. We got about 40 people in here. What do you guys think? Do you guys want me to do these lives? Do you want me to do these lives more often? What do you guys think? You think it's entertaining, informative, kind of get the forecast? Do you want me to be like more informative, or do you want me to be kind of like more broad and kind of use more like easy to understand terms? What do you guys think? I need your opinions here. And then we'll go ahead and shut it down. You guys like it? I want to keep doing these. It's going to be tough to do when I'm on the road chasing, but when I'm at home, I can do these. And we kept going up in viewers, and then apparently I started lagging and my Wi-Fi cut off. So after the Wi-Fi cut off, we went back down to like 30, 40, and we kind of just stuck there. So nerd out. Barry says nerd out. Well, appreciate everyone for tuning into the stream here. We were live for maybe an hour. I'm not sure. Maybe an hour. That's pretty good. Live for maybe an hour. Tomorrow night, I'm going to try to go live between 8:30 and 9. So it'll be earlier. I don't like going live at like midnight, but very informative. But let me get my laptop here so I can shut this stream off. But I'm glad you guys enjoyed it. You guys kind of get to see what I kind of am thinking when I'm trying to plan my chases out. Okay, I haven't seen any no's in the chat, so clearly you guys want me to do it again. But sorry about that. I had a little technical difficulty there in the middle of the stream. But with that being said, I'm going to go ahead and get out of here. It's almost midnight. But good night, everybody, and I will be back tomorrow around 8:30. I'm going to go ahead and schedule that stream right now. So you guys have a great rest of your day. And keep on keeping on. I don't really know what else to say. So